So good morning children. So in the previous class we discussed about how valency is differing along the period and down the group. Down the group the valency remains the same, but along the period initially it will increase from electropositive and gradually becomes electronegative and decreasing in the value, finally becoming a zero valency in the 18th group element. Now today let us see how the atomic size is going to differ down the group and along the period. Now observe this figure children. I have just drawn the second period elements and the first group elements. Now let us see along the down the group. Now down the group, if you observe children, as you observe in the outermost shell the electron is only 1. Okay, so the valence electron is same, but where is the valence electron is entering into the new shell. So as a new shell is added, the distance from the nucleus to the outermost shell increases, isn't it? So the atomic radius is increasing, and as atomic radius increases, obviously the atomic size also increases. Am I clear? So now children, as a new shell is added and as the distance increases, the nuclear force of attraction between the nucleus and the electron in the outermost shell also decreases. That is why the electron can be readily lost by a larger atom. So let us come back to our point. Atomic size down the group will increase because a new shell is added and the force of attraction between the valence electron and the nucleus also decreases. But then come along the period. Along the period, if you see if I take up the configuration of lithium, it is 2s1. Then beryllium is how much children? 2s2. Boron S2P1. So what has happened? The electron keeps on entering into the same shell. Till when? Till the electron gets filled up in the shell, isn't it? So if you see now here, in the second period, it starts with lithium and ends with neon, where neon has a configuration of S2P6. That means the electrons are filled in the same shell. So now what have you observed? Along the period, the atomic size decreases. Now you may have a question, electron is entering into the same shell, why it should decrease? The reason is, as the new electron is added into the same shell, the force of attraction between the nucleus and the electron will be increasing. Thereby, the new electrons are pulled towards the nucleus, thus shrinking the size. So, along the period, atomic size decreases, but down the group, atomic size increases. And why it increases? As a new shell is added. And why it decreases along the period? Because the force of attraction, the electronic charge is increasing, hence the force of attraction increasing. So the electrons are pulled towards the nucleus, hence the size decreases. So I hope you are clear with this, how the atomic size will vary down the group and along the period.